Hi, I'm Dr. Murray Conley, and today we're going to talk about your fats or adipose tissue. Everyone has it just in varying amounts and stored in different places in the body. Fat is really the most efficient way for your body to store excess energy to use later. So when you eat excess calories from food, whatever is not used as fuel is stored as fat, which is made up of triglycerides. One triglyceride is made up of three fatty acids attached to a glycerol molecule. A typical fat cell is made up of one large expandable fat droplet surrounded by a cell membrane and a small cell nucleus that's pushed to one side of the cell. Unlike other cells in the body, a fat cell can expand to great sizes if it needs to store a lot of fat. For example, a white fat cell can expand from 10 micrometers to 100 micrometers in diameter before it starts to run out of oxygen supply from the closest blood vessel. Your fat mass is determined by your body's balance between lipogenesis, building fat, and lipolysis, or breaking down fat. Excess nutrients are converted to fat in the liver and then packaged into particles like chylomicrons and very low density lipoproteins, or VLDL. These particles carry fat and cholesterol through your bloodstream. An enzyme attached to the inside wall of capillaries called lipoprotein lipase can break down the fatty acids that are stored inside those chylomicrons and VLDL particles. The free fatty acids could then leave the capillary and enter a nearby fat cell, either by simple diffusion or via a protein carrier embedded in the membrane of the fat cell. The fatty acids then combine with others to form triglycerides, which then fuse with the one large lipid droplet in the fat cell. In the fasting state, your body needs to break down fat to use it as energy. Hormones and catecholamines like leptin and norepinephrine can trigger an enzyme inside the fat cell called hormone sensitive lipase. When triggered, this enzyme breaks down triglycerides into free fatty acids, which then can leave the fat cell and enter the blood to be used elsewhere in the body. This is a process of energy homeostasis that occurs in healthy fat cells. If your calorie intake is too high, you have a constant supply of fatty acids in the bloodstream needing to be stored somewhere, stored in white fat cells. These fat cells can expand like a balloon to a certain size before becoming starved of oxygen. At this point, the fat cell becomes dysfunctional and can no longer take in any new fatty acids. Fatty acids then build up in the blood and the overflow deposits to organs that are not typically meant to carry fat, like the liver, pancreas, muscle, and kidneys. Products of fatty acid metabolism also build up inside the fat cell, causing even more inflammation. Certain scavenger cells in your immune system, called macrophages, migrate through the bloodstream and enter adipose tissue to get rid of these dying fat cells. These phagocytes, in Greek, eating cells, join the resident macrophages that are already present in adipose tissue. Together, these adipose tissue macrophages surround and gobble up the dying and inflamed fat cells. Inflammatory cytokines such as TNF alpha and interleukin 6 are released. These damaging proteins cause chronic inflammation in the body and promote tumor formation, development of diabetes, and Alzheimer's dementia. The human body was designed to carry healthy fat, which effectively regulates your energy balance at any period of time. Over thousands of years, our body has evolved to effectively store energy as fat in times of famine. However, When we have a constant supply of food and little need to move, our fat cells can hypertrophy or expand to unhealthy sizes, causing them to become inflamed and die off. This triggers inflammation and disease throughout the body. Thank you for listening. I hope this is helpful for you.